Okay, so today we're going to be working on calculating means and standard deviation of discrete distributions. And we have some formulas, and I know they look scary. I will tell you that the variance and standard deviation formula is one you saw on page 50 of your notes file, and I said that at some point we're going to talk to you about it, and you'll find out it's not that bad. Today is that day you find out it's not that bad, although it does look a bit scary. This right here, you already know how to do. It's just the symbols and the way it's put together you didn't know, you hadn't seen before. So basically, if you're calculating the mean, you're just calculating an average. And you know that when you calculate an average, all you're doing is adding up all the values and dividing by the number of values you had. That's what this means. The summation means add. So add up all the values and divide however many you have by however many you have. And that gives you the mean. And that is the Greek letter mu for population mean. That's all that is. We'll come back to variance and standard deviation in just a moment. So in this case, when working with discrete distributions, what if we had a list of data and we knew how often certain results occurred? For instance, when we roll a die, a six-sided die, we can get a 1, 2, 3, 4, 5, or 6. And we know that each probability is 1, 6, 1, 6, 1, 6, 1, 6, and 1, 6. All right? So in this case, our distribution, our values, 1, 2, 3, 4, and 5, and 6 are distributed in a uniform manner with a probability of 1, 6. Now, real quickly, we have a couple things to talk about probability. And yes, we are going to discuss probability briefly. This is not the probability section of the class. But to be a valid probability distribution, the sum of all probabilities must be 1, which in this case they are. 1, 6 plus 1, 6 plus 1, 6 plus 1, 6 plus 1, 6 does equals 1. We don't care about the x values. We just care about the probabilities. They have to add up to 1. And there's no such thing as a negative probability, and there's no such thing as a probability greater than 1. So all the probabilities must be between 0 and 1 inclusive. All right, 0 and 1 inclusive. There's no negative and there's no greater than 1. If it's a probability of a 0, it means it can never, ever possibly occur. And if it's 1, it means it happens every single time. All right? So the question is, does this represent a valid probability distribution? Does that table? And the answer is yes, because all the values lay between 0 and 1. And they all add up to sum to 1. Okay? However, I have to show my work, all right? So I need to show my work on how to do this. So every time you do this on a test or a quiz, you're going to need to show your work, and this is the way you do so. This is the formula, and it will be on a formula chart, so you will always have this. The expected value just means on average, what do you expect? These two terms are mostly interchangeable, not 100%. They're pretty close to being interchangeable. What do you expect to happen? On average, what's going to happen? And you're going to sum up all the x's and multiply by their probabilities. Well, what x's did we have? Well, this was my x list, which is 1, 2, 3, 4, 5, and 6. And how often can a 1 happen? Well, 1/6 plus 2 times 1/6. So 1/6 times 1 plus 1/6 times 2 plus 1/6 times 3 plus 1/6 times 4 plus 1/6 times 5 plus 1/6 times 6 equals 3.5. So when you roll a dice, you actually expect to get a 3.5. And you go, wait a minute, Mr. Spencer. I've rolled dice before. There's not even a 3. You can't get a 3.5. You're right. You can't get a 3.5. You can get a 1, 2, 3, 4, 5, or 6. But if I averaged all my rolls together, if I added them all up and divided, I would expect this to be 3.5. Now, the nice thing is the calculator does this really neatly for us, okay? So I'm going to go second quit to get to a clear screen. You'll have to excuse my printer in the background. It wants to interrupt us. So we press Stat, then Edit. And you probably can't see this, but I typed in 1, 2, 3, 4, 5, and 6 in the column L1. So in column L1, I just want, all I did was go 1 enter, 2 enter, 3 enter, 4 enter, 5 enter, and 6 enter. And then in column L2, I put the probabilities. Well, the probabilities were 1, 6. So I went 1 divided by 6. And then 1 divided by 6, enter. And I did that all the way down. And that ultimately gave me all my probabilities. So at that point, I can leave that, second quit, and I can go stat calc, one variable statistics. My list, or my X list, is an L1, so second one. And then I do have a freq list. My freq list is my frequency. And my frequency for all of those were put into L2, so I press second, followed by the number 2. Sorry that you can't see that. And I'll press enter. Now press enter. And I get up a whole bunch of information. So they tell me X bar equals 3.5. So that means my average is 3.5, and that's what we said it was going to equal. They also tell me my standard deviation equals 1.7078, and that'll be good enough. All right, 1.7078. Now, so we know how to write the mean. Make sure you always write the formula and show this work if you're doing this on a test or quiz. As far as calculator, you just put it into the calculator as I showed you. All right, so the next thing is, how do you calculate the variance? Well, we almost calculated the variance already because we calculated the standard deviation. Well, variance is, as we talked about earlier, is just standard deviation squared. So I just need to come back and square that number. All right. Now, so I mean, I'd run it through the calculator just the way I did, square that number, and I'll get 2.917, or approximately. But how does the formula work? Because you have to show your work. So this is the formula that you need to record every single time. Okay. Well, this is my X value. So this could be a 1 or 2 or 3 or 4 or 5 or 6. We're rolling a dice, and that's what you can get. And this is my average. Oh, we just calculated the average. We calculated the average as being 3.5. So we're going to write 1 minus 3.5 in parentheses and square it. Now we have this thing called piece of I. That's the probability. What's the probability of getting a 1? The probability of getting a 1 is 1/6. Or I could have gotten a 2. So parentheses 2 minus 3.5 squared times that's probability. The probability of a 2 is 1/6, and so on and so forth until we all get all the way to 6 minus 3.5 squared times 1/6, and that equals 2.917. And I'll just go ahead and show you that. Actually, I don't think you can actually see it because the calculator screen is backlit. So 1.7078, if I square it, I get about 2.917, which is what I said would happen. All right. All right. So standard deviation. Standard deviation is the variance formula, but take the square root. Because all we did was put the variance formula under the square root, and there we go. So basically, if I wanted to show my work, which I'm required to do, I'd write this formula, and then I just put it under a square root sign, and I'd be good to go. All right. That's how to run it on the calculator. Let's do a couple little quick problems. And by the way, you're going to do some calculations of these this week on some assignments. But next week, will actually be more, I'll more expect you to be able to write this stuff out. For the time being, it's good enough to be able to put it in the calculator and just run it through the calculator. So with that said, I'm going to go ahead and pause the recording and switch. Okay. Hopefully we've gotten the share right. I don't think I have, so I'm going to pause this thing. All right, so hopefully you're able to see the completed set of notes. And it says a commuter must, and this is page 67 of the note spiral, The commuter must pass through 5 traffic lights on her way to work. She estimates the probability model for the number of lights she hits as shown below. Calculate the expected value, mean, and the standard deviation and variance showing all work. Well, we're not going to worry about showing work today. We're just going to worry about getting this done. So I'm going to put in the calculator. We're just going to worry about the calculator. So I'll put in 0, 1, 2, 3, 4, 5 into one column. And then to the next column, I'm going to put 0.10, 0.25, 0.3. These are my frequencies. So when I put them in, I should end up getting something that looks like this. Well, what do you know? I lost a list. So let me see if I can get that list back. Enter. There we go. 0, 1, 2, 3, 4, 5. I put in a first column, the 0.1, the 0.25, the 0.3, et cetera, I put in a second column. So here we go. We're going to go ahead and do our calculations. I'm going to get to a clear screen because I like doing that. I'm going to go stat, calc, one variable statistics. My X list is an L1. And then my frequency happens to be an L2 for this. And I press calculate, and I find out that I get a mean of 2.1 and a standard deviation of 1.3. It didn't give me the variance, so to get the variance, I'll have to square that value. So there's a 2.1, 1.3, and 1.3 squared is 1.69. So that's a fairly easy problem to do in the calculator. It's a fair amount of writing by hand, but in the calculator, it's fairly easy. The next part of that question says, does the above scenario represent a valid probability distribution? And the answer is yes. All the probabilities are between 0 and 1. There's no negative probability. And when I sum them up, they sum to an entire 1. So that's easy to do. Showing my work, I go 0 times 0.1 plus 1 times 0.25, etc. All right, calculating the variance. 0 minus my average, which was 2.1 right here, times the associated probability of a 0. Then 1 minus my average, that squared, times the associated probability of 0.2, which is 0.25, all the way through to 5 minus my average of 2.1, square that value and multiply it by the probability of 0.05, and that gives me 1.69. To get the standard deviation, I would just take the square root of that 1.69 or the square root of that whole thing. It says complete the probability distribution, calculate the expected value and the standard deviation for the following. All right, so for the following, I can expect to have 2, 4, 6, and 8. Those are my X's. But right here, I'm missing a probability. But I know that it has to add up to 1. So when I add all these up, I can subtract that from 1, and I find out that 8 has to have a probability of 0.2. So this is what this looks like. So I'm going to go to Stat Edit, and I enter the data. So I have 2, 4, 5, 6, 8, and I put that in column L3, and in column L4, I put in the associated probabilities, including the 0.2 for the 8. Now, stat, calc, one variable statistics. Now my X list is an L3, so second followed by 3. Enter. And then second 4 for my frequencies. And I find out that I have an average of 5.2, a standard deviation of 1.939, and if I square that standard deviation, it's about 3.76. Depending on your rounding, and I'm not too concerned about the rounding at this point. Okay, last one. The last one's a bit tricky. So an insurance company charges $1,600 for car insurance. The policy specifies that the company will pay $3,000 for a minor accident and $10,000 for a major accident. The probability of a motorist having a minor accident during the year is 0.22. And having a major accident is 0.03. So basically they're telling you that the probability of an accident, of some sort of accident, is 0.25. So the probability that they don't have an accident is 1 minus 0.25 or the 0.75 we have right here. All of these sum to one whole. All right, so we have a valid probability distribution because everything's one whole, sums to one whole, and it lies within the interval 0 to 1 inclusive. Complete the probability table below for how much money the insurance company will make on a single policy. Well, wait a second. Some policies, they make money. Some policies, they lose money. So they're not asking you what they make on a single policy. On average, what do they make for every policy they sell? Well, they're selling them for $1,600. However, if you have a minor accident and they have to pay out $3,000, 3,000 minus 1,600 means they lost $1,400. So if you have a minor accident, they lose $1,400. If you have a major accident, you paid them $1,600, but they're losing $10,000. So their net difference or their net loss is $8,400 if you have a major accident. All right, so now we know the X values, we have our probabilities, and we can go ahead and enter those into the calculator. Now, stat edit, in my case, I have those in L5, and you can't see it, but I also have it in L6. So stat, calc, one variable statistics, second 5, enter, second 6, enter, and calculate. And somehow or another, I have something wrong. So let me go to my stat edit real quickly and see if I have something wrong, what it is I have wrong. Teachers make mistakes too. I make them all the time. So that looks good. I have 75 instead of 0.75. That is probably why. Let's try this again. 0.75. Enter. All right. So stat, calc, one variable statistics. And on average, they make $640. So you're paying them $1,600, and $640 of that is profit for them on average. Once again, some policies they lose money, others they make money. The standard deviation is $2,014.55. And if I square that, I'm sorry, but these two values are switched. The 400, shoot, I can't even read that number. That 4,058,400 is the variance, so it should have been squared. This over here is a standard deviation. I swapped those two numbers, and I apologize for that. I just now caught it. All right, so you know how to do this in a calculator. You will have some to practice with this week, and we will revisit this the following week as well. All right, thank you.